All right, so we want to look at the question. We want to find constants a and b. So the function defined by ax times e to the bx has a local maximum at 1/8, 1. So our answer, since f of 1/8 equals 1, this tells me that 1 equals a times 1/8 times e to the 1/8 times b. It's simply plugging in the information that f of 1/8 equals 1. Cleaning this up a little bit, you can rewrite this as 8 over a equals e to the b over 8. But we're kind of stuck there for the time being, we have one equation but two unknown variables. We also know that 1/8, 1 is a critical point, which means we can analyze the derivative. F prime of x should equal a times e to the bx plus ax times e to the bx times b, using the product rule and the chain rule in the last part. Now, we need to analyze this, so cleaning up might be beneficial. I can factor out an a e to the bx, leaving me with 1 plus bx. Just factoring out what you have in common, leaving it alone. Since this thing never fails to exist, f prime of 1/8 must equal 0, which implies that 0 equals a e to the b over 8 times 1 plus b over 8. This term here cannot be 0. Assuming if a was 0, then this function is the constant 0 function, and we can't do that. So this needs to be 0, and therefore b should equal -8, a few steps of algebra there. A e to the b over 8, yes. It's a times e to the b times 1/8, which I wrote as b over 8. This information solves half the problem. The other half can now be solved from right here. So taking that information and putting it in, 8 over a equals e to the -8 over 8, or that 8 over a equals e to the -1. Reciprocating everything, a over 8 equals e to the first power now, or that a equals 8e. So f of x, using our newly found constants, is 8e x times e to the -8x. So we found a to be 8e, and we found b to be -8.